and let me share the screen. Okay, let me announce some of these software testing tools which could be used in practice in several situations. First of all, we announced you a categorization of different software testing tools. There are several test tools for doing functional testing and regression testing. As you know from the class, as you learned from the class, we have to type two general categories of testing activity: the functional testing and non-functional testing. And I have told about both of them in this semester. For example, when we try to test the performance of software product, actually we evaluate the quality of the product, and we evaluate a quality attribute of the product or a non-functional requirement of the product. So there are several tools for functional testing, and there are several other tools for a non-functional attribute or non-functional requirements, and both of them are considered in this lecture. So let me announce a good list of the very frequently used software tools. The first categorization, the first category of these software tools focus on functional testing and regression testing. And as you know, the regression testing is done when a software changed. When we repair some part of the software, when we add a capability to a software, we should do test again the software, but there is no need to test entire of the software and run all the tests as I generated by developing phase, by the whole developing phases of the software. But there is need to test the parts of the software that has been changed in regression testing. So there are several tools for this testing this type of software activity. And the next set of tools focused on performance testing of software. For example, for doing load testing or doing stress testing, we should use some special software testing tools to do tests, to run tests automatically and report the result of the testing. And the third category is about mobile test tools. As you know, the mobile applications have their own characteristics, and they are categorized in a type of mobile applications, and the testing issues in mobile applications in several situations may be different with other applications, and there is necessary to use special software test tools to test these type of applications or software products. The other two category focused on the activities such as test management or the defect management software tools, and there are several tools again for this category. Let me go ahead and see numbers of each of these software testing tools. As you see in this slide, there are several different software testing tools informed in this slide for functional and regression test. For example, the Selenium platform is an open source software testing tools and free software testing tool that you can use it for testing your web applications or web services as well as possible. And another testing software testing tool is a unified functional testing tool or QTP or UFT in short. This is again a software testing tool that help us to automatically run our tests and taking its reports to promote our software quality. There are some others, as I know some of them. I work with Cucumber software testing tool. I known the Test Complete. These software tools are very famous in testing communities. What and SoapUI. SoapUI is an open source software testing tool again, and you can easily download both the executed format and the source of the SoapUI and see how they designed and implemented a software testing tool. Let me see your messages. These tools for testers. These tools are for testers, but in some companies, the developers also done their tests, so developers can use these software testing tools again. Can you hear me clearly? The sound is cut. Okay. Let me go ahead, please. So, as I know, some of them are more famous than others. I know Selenium platform, I know SoapUI, Test Complete, and Cucumber in that are used in very famous company and prestige projects. So you can search about them, and there are several video materials on YouTube for each of them. You can learn about all of them easily by using those video materials, and you can download some of them easily, especially those are which are open source tools, and some of them are vendored by some companies, and you should purchase them or buy them. You should pay money for taking them, but some others are free and more even open source tools, and you can use them in several platforms such as in Windows, in Unix or Mac, and they are applicable for several projects such as web-based project or desktop projects, and you can search about them more if you want. And for the second category of testing activity, the performance testing, to testing performance, there are several testing tools that help us in doing the stress testing, for example, and load testing, and several other performance related quality attributes such as response time and number of users could be respond at the peak, and several other attributes such as measuring the throughput, the efficiency or reliability of our software. The most famous tools are load runner and JMeter. I've downloaded the JMeter before the class, and the using of this tool is very easy. You can use them very easily. You can, for example, you can define several threads, each thread for a user on your computer, and send requests from each user to your server to testing, for example, the load testing of your web server or your web applications, as well as that could be done for database requests could be performed by JMeter, and this is again could be done by load runner. You can download the load runner and use them. The JMeter especially is an open source software testing tool or performance testing tool, and you can download the source of the JMeter, and you can do a reverse engineering on its architecture and see its components, and how to see how it was implemented. Some others are, as I know, less famous for performance testing, but they are also be used in industry. For the third category of testing tools, or for mobile test, as I know, the Appium testing tools is the most famous testing framework for mobile applications, and there are numbers of other testing tools that you can search and learn how to use them in testing your mobile applications, as well as other type of applications. I talked about them in previous categories. But for test management tools and defect management tools, there are some other tools like as Bugzilla, IBM Rational Clear Quest, Maybe some of you be familiar with some of these tools, and there is a famous testing tools, test management tool that is not considered in this slide, the Jira, G-I-R-A. The Jira testing tool is another famous testing tool that is used for test management activities or defect management activities. Okay, you can see the demo of these tools from their vendor sites, and use other materials such as videos that are presented in YouTube. Okay, if you have questions, please ask your questions about these tools. You can select one of these tools. Each of you can select one of these tools and search about how to install, how to use these tools in practice, and make a representation for each of them in about 15 minutes. A short introduction to how using each of these tools. This could be considered instead of instead of doing the several exercises or the exercises at the end of each chapter. Okay, no problem. Be cautious. I want to take exam. In time about the concepts of the concepts that presented in the class in the entire of this semester, and you can do this for extra marks. You can do this activity for extra marks, no problem in this area. Let me go back to our slides, but before we return to our slides, we ask again in this session we can have one representation of you. If any one of you is ready for doing the representation, doing him or his or her representation, no problem, you can do it in this session. We have no any more time for your representation when we want to represent your study project. I've considered 6 marks for your representation and 4 marks for implementation of your research papers. In case of review papers, you can select one of these tools for 4 marks. When you want to do these activities, I have no time. Some of you has sent the video of their representations, but it's not acceptable because we want to discuss about your problem, about your solutions, about your analysis of your results in the paper, and we want to discuss about new notions or new issues at your selected problem in this class, in the class. The explaining the paper has 6 marks, as I told you in the first session, and its implementation has 4 marks. Altogether, they have 10 marks. I want you to start your representation at next session, and the time could not be extended more. Okay, if no one of you is ready, I continue to our course. As you know, in a previous lecture, we talked about how to extract control flow graph from source code, and we talked about several structures such as if structure, if else structure, loop structures, and we have explained how to extract control flow graph from these structures, and as you know, we reached to the if I remember true, we reached to this slide. Okay. This slide says about how to create a control flow graph for do loop structure, and talk about how a break statement and continuous statement change the flow of control of our program, and let me to explain each of them according to suitable examples, suitable pieces of code. Suppose we have a program, a piece of program such as showed in this box. In this piece of code, first of all, x is initialized by 0, and a do-while loop is used. In the body of the loop, we have two statements, two assignment statements, and the while is conditioned by this Boolean structure, this logical structure, and finally a return statement is used to return the value of y variable. How we can create a control flow graph for this piece of code? First of all, we should define a location numbered 1 to do this statement to let x to be 0, and then we should go to the next to another statement to doing the do-while loop, the statements of do-while loop. As you see, the statements that should be run at this location or at this state are these two statements. Then we repeat these statements if x be less than y. So we have a self edge, we have a self loop. If x be less than y, these two statements will be repeated again, and this will be continued until the x be greater than or equal y, such as this showed in this edge. And at this situation, we go to another location, such as location 3, and at this location we run this statement, we run the return statement, so this location will be a final location or final state. I hope you learn clearly how to create control flow graph for do-while loop, and let me to explain how break and continue statements can change the flow of control of our programs. As you see at this next example, we have a while loop in which we have used a break statement and continue statement in its conditional structure. First of all, when we enter to the while loop, we set y by the value of return value of the function f. By this function call, we calculate the value that should be stored in y, and then if y be 0, we should break the while loop and go to the return. Else, if y be less than 0, we set y to this expression, the result of this expression, and then continue. When we execute this statement, the control of the program go to the while again and start by executing another time the loop statements. Okay, so let me draw the control flow graph step by step. In the first step, as you know, we should have a location that set x to 0. In the next step, we should go to the dummy statement, dummy state or dummy location to start the while loop. As you learned in previous lecture, for some loops such as for loop or such as while loop, we should define some dummy statements, dummy states or dummy locations to define the control flow graph for these structures properly. So at this state, we start to entering the while loop, and we should check the condition of the loop, and so we have two branch from this statement. So the first branch is when the condition of the while be violated, when x is not less than y. So the condition is violated and the condition returns false, and we skip the while loop and go to the return statement. The return statement defines a final state, defines a final location. On the other hand, when x be less than y, we go into the loop and run the body of the loop in a proper way. Let me go to the loop. In the first step, we should execute this statement, and then we should define a branch for if statement, such as this. When y be 0, we go to this statement, which is a break statement. As you know, when we use break statement in a loop, we go out from the loop and continue to the body of the program after the loop, such as this. When a break statement be executed, we go out from the loop and go to the statement just located after the loop. As you know, the end of this while loop is at here, and the next statement will be return y. So the break statement can change the flow of control to go to the return y. Otherwise, we check the y according to 0. If y be less than 0, we continue to execution of this statement and then continue the loop for next y, for the new y. Okay, so else if y be 0, we go to the break. Else we should check again y according to 0 number, such as this. At this state, we also have a branch condition. One branch, let me see, one branch go to the continue, go to this statement, and the other one go to this statement after the if else structure. So the first branch is taken when y be less than 0. When y be less than 0, these two statements should be executed at this state. And as you know, we continue change the control flow to the entrance of the loop for the next time. So to continue, go to the starting of the loop, and otherwise if y be greater or greater than 0, we should go to this statement and then come back to the first state of the while loop. So otherwise we should execute this statement at this state and come back to the first state of the loop. Okay. So you have learned about how break and continue statements change the flow of control, and how do loop could be used in control flow graph. Let me see your message. Yes, there are two conditions. The first condition is this one, and the second one is this one. So we have two branches, one at this state and one at this state. Okay. Okay. Another structure that should be modeled in control flow graph is the switch case structure. As you know, when we have several conditions, our conditions should be of equality type. We can use switch cases in our programs. For example, in this piece of code, you see that we read variable c from input, and we should compare the value of c with several specific values such as n, y, and otherwise. And in each type we should do its own statement. For example, when c be n, we should assign the z to be 25, and when this character be y, we should assign the 15 to the variable x, and then break to go out from the switch case and go to the first statement just located after the switch case structure. And otherwise, the default portion of this structure said us that when c be not n and not y, then we should execute these two statements. Okay, let me to draw the control graph. First of all, we should read the character c from the input, and then we should compare this character with n, with y, and otherwise go to the default part. So if the character c be equal with n, we go to this state to run this statement. And then, as you know, as you see, there is no break statement at this point. So we go to the next case automatically. We go to the next case. The next case is when the character C equal of Y. Okay, when C be Y, we go to this state. Okay, then at this state we let X be 15 and then break, go out from the switch case. We execute this statement and break statement, go to the next state which run this statement, print X. And this statement, according to this piece of code, is a final state. Okay, and when the character C be have other values except Y and N, we go to the default part. In the default part, we run these two statements. These two statements should be executed, and then the break statement take the control and go to the 5 state. Okay. And what about the exceptions? As you know, we use a try-catch exceptions, try-catch structure to handle the exceptions, various exceptions in our program, such as this one that we use to catch a statement. We use a try-catch for IO exception and extra exception E at this piece of code. So in the try block, we read a line from a file, for example, and store it to the variable S. Then if the length of S be greater than 96, we should throw a new exception, too long. And if the length of S be 0, we throw another exception which say that is too short. And in the catch block of this code, we catch two type of exceptions. The first one is IO exception. The IO exception could be thrown when, for example, this file handler be null. When this file handler be null value, has a null value, so we can see IO exception. And when the IO exception is thrown, this print stack trace should be executed. And otherwise, in two other cases, such as exceptions for too long line or too short line, should be handled at this location by a proper message. Okay, and finally we return S if S be a null value. Let me to see the control flow graph. As you see, in the first state of the control flow graph, this statement is run, and then we have a branch to check the length of S with 96. If the length of S be greater than 96, excuse me, we start, let me see, we check the length of S at this state, because if this handler of file, for example, be null value, an IO exception could be thrown by this method. So at this state, at this location, we have a branch, the one for usual call of read line, another one for call for a null object. So an IO exception could be thrown. Okay, and when we go to the usual state, such as 3, then I can check the length of S variable according to 96 at this stage, and when this condition be true, we throw an exception, else we should check with 0. Okay, so in this state we go to the throw exception at new state, and otherwise we go to another state for executing this condition, this conditional statement. If length be 0, we throw new exception again at state 7, and otherwise we go to return. Okay, let me otherwise is related to this edge. When length be not equal to 0, we go to return statement. But at this stage, when an exception was handled at this situation, and so on for this statement, we go to return statement again. So this could be happen at this state and at this one. Okay, this slide show a complex example of try-catch exception, in which we have several exceptions, such as IO exception, by which is implicitly be thrown by this method call. IO exception is implicitly defined by this method call, and two explicit exceptions in these two if structures, and then we have two catch exceptions, two different catch exception. So this example is not so easy, and this is a complex example. Let me see your message. Return the try catch. No, the try catch, the catch part should be handled. It means that, for example, we should print some messages on console, or we should process the exception by making extra computation. So the catch portion is not equal to return statement. The return statement defines a final state, but the catch exception statement defines non-final state. Okay, they are different. The try catch and return statement are two different structures according to control flow graph structures. So let me explain a complete method to see how we make a control flow graph. As you see in this method, we have a parameter, a number parameter. As you know, parameters defines some variable, defines some input. So this could be considered as a define statement, as a diff statement in data flow graph. I use it later. In the first statement, the length of this array is stored in the length variable, and several variables such as med, var, this is a variance, this is a median, this is a standard deviation, this is a mean, sum, and var some variables at the second statement. At the third statement, the sum is initialized by 0. As we know from previous slides, these all three statements should be considered in a state. So in the first state of the control flow graph, we should execute these three statements at the first location. So let me see. In the first location we have these three statements. Then we should go to the for structure. As you know, in for structure, an index I should be defined and initialized first of all. Then I should be compared with length. If I be less than length, we go into for statement, for structure, and we should done all statements in the for structure. Then we should increment the index of the for loop and go back to the conditional statement of the for structure to check if I be less than length again or not. If it be true, we go into the loop again and repeat the body of the for loop, and otherwise we go out from loop and continue to the next statements of the program. So we should define the for structure in our control flow graph by defining a new location to set the index of the for loop to 0, and then we go into the for loop or skip the loop. So in this statement we have a branch for one for the situation when I be less than length, or one for otherwise. So the conditional statement is checked in this state this is a dummy state in our control flow graph, and when we go into the loop, we should execute the body of the loop at this state, and then come back to the loop. When we come back to the loop, we increment the index of the loop and then compare it again with the length variable. Okay, and when we go the loop, we should run these three consecutive statements, these three sequence of statements. The first one set the mediation of a number to the element which is located in the middle of this array, and the mean of the numbers should be calculated by the summation of its elements slash the length of the number of elements, which is counted by the length variable. So the mean variable could be calculated by this statement, and the var sum is initialized by 0 at this statement. All of these three statements should be executed in a next location, say location 5. And we can continue by executing the next four structure this as the same as the first loop structure. For doing this, we should define a dummy state for initializing the index I, and then go into the loop and calculate the var sum variable at the state 7, and then come back, increment the index of the loop, and come back to the condition of the loop to check if we go to the loop again or go out from the loop. When we go away from the loop, we should execute all of these block. This is a basic block that's considered for location 8, and they are be done in this location. This control flow graph, as you see, is augmented by some labels for some of its nodes and its edge. For example, this node is augmented by this label, which said that the initialization of index should be done at this location, and then it should be checked in the next location. So in this location, we have a branch condition and define two branches, as you see, and other several labels considered for other nodes and edge. Let me see your messages. Your messages are too long. Let me read them after the class, after the lecture. Excuse me. We define a proper test cases to cover the test requirements. So we have this control flow graph. And for the coverage criteria, as you know, as edge coverage, we should cover all edges of this control flow graph. So the test requirements for edge coverage be all of these edges, the edge which started from node 1 to node 2, node 2 to node 3, node 3 to node 4, 4 to 3, 3 to 5, 5 to 6, 6 to 7, 7 to 6, and 6 to 8 are all edges of this control flow graph. All of them are our test create our test requirements set for edge coverage criteria, and we should define some test passes to cover all of these test requirements. As you know, when we have a test case that run according to this test pass, one loop, each loop once, to execute each loop once, at least once, we can cover all edges. So this is a simple pass which cover all our test requirements. As you can see, this pass 1, 2, 3, 4, 3 again, 5, 6, 7, and 6 again, and then go to 8. As you see at this array, at this list, can cover all edges of this control flow graph. This is a simple coverage criteria, and by one test case we can cover all of our test requirements. And another coverage criteria, as we have learned in this class, is edge pair coverage. For edge pair coverage, we should define all possible edge pairs of this control flow graph as our test requirements set, and all of them could be 1, 2, 3, 2, 3, 4, 3, 4, 3, 4, 3, 5, 2, 3, 5, 5, 6, 7, 5, 6, 8, 6, 7, 6 again, 7, 6, and 8. All of these edge pairs should be considered as our test requirement for edge pair coverage, and we should define some test passes to cover all of these test requirements. As you see, there are 3 test passes that we should check to cover all of our test requirements. The first one, as you know, we go from node 1 to node 2 to 3 to 4 to 3 again. So in this test pass, we do the loop once, and we have a side trip. We have a side trip from edge C to edge H. All of these edge pairs have named by some characters. Each edge pair is defined by a character, has a name. The edge pair C and edge pair H is used as a side trip for the first test pass. The edge pair C is this edge pair 2 to 3 to 5. Skip the loop, and the other edge pair H H defines this H pair, when we go through this H pair, we skip this loop again and skip the side strip. We have two side strips in this control flow graph, and they could be skipped by these H pairs and this H pair. Okay. These H pairs should be covered at next test passes, like the second one and the third one. And if you check, you will see that the first test case the test pass can be covered by the as I guess by the third test pass. The third test pass again covered all test requirements that are covered by this test pass. So this test pass could be omitted from our test passes, and we have just two test passes. We should define two test cases to go through these test passes. The other test coverage criteria is prime pass coverage, and for prime pass coverage you should count all prime passes from this control flow graph. As you have learned from previous lectures, they are listed in this box, and there are some test passes for covering these prime passes, and they are mutually evaluated against each other to delete or omit extra test passes. As you know, in practice, the control flow graphs could be very complicated, very bigger than these ones, and counting all test requirements could be very hard to do manually. So we should use some automatic tools to define test requirements and to guess the proper test passes to cover these test requirements. I want to introduce you some web applications from Jeff Offutt website to do these tasks. Before I go to the website, let me see your messages again. Who is decided the length of how is decided the length of test requirement? The test requirements, the size of test requirements, or the number of test requirements could be defined by the control flow graph. The control flow graph determine the control flow graph set defines a set of test requirements in each of coverage criteria. So the number of them are not optional. They could be defined correctly to a specific number, because there are no optional tasks in determining the test coverage criteria, test requirements. They are strict. Okay, let me go to the Professor Outlook website to show you a number of web application which could be used in defining test requirements and defining test passes. I search introduction to software testing. Introduction to software testing with Jeff Hoffman. This link is that we want, and we go to the home page of the book. There are some support software to concepts of chapter 7. The first one is about graph coverage web application. The second one is about data flow coverage web application, and so on for other coverage criteria for all other structures such as logic and DNF and others. We want to go to this page to see how to use this web application to extract our test requirements according to the graph. As you know, the graph is this one, and we should inform the graph to the tool and use the tool to extract several test requirements according to several different coverage criteria. For informing the control flow graph to the graph, we should define all edges of the graph, and the tool automatically determine how to shape the graph. So the edges include edge 1 to 2, 2 to 3, 3 to 4, 4 to 3. We want to enter some of them. The edge should be entered such as this. The first node is space, then the second node, the node 2 to node 3, 3 to 4, 4 to 3 again, and then the other edge, as you see, 3 to 5, 5 to 6, 3 to 5, 5 to 6, and then let me see, 6 to 7, 7 to 6 again, 6 to 7, excuse me, 7 to 6 again, and then finally the final edge is 6 to 8, as you see here. Okay, so this is this set of edges define our control flow graph, and we should define the initial node and the final node. The only initial node of our control flow graph is the first node, and the final node is the node 8. So we define the node 8 as final node. So by these 3 boxes, we have defined our control flow graph. These are all of our edges, and this is the first state and this is the last or final state. So as you know, we have several coverage criteria based on graph concept. We could define the node coverage criteria, the edge coverage criteria. These two are simple, but defining the edge pair, simple passes and prime passes could be difficult. We can use two algorithms for defining passes to cover the coverage criteria. For defining the test requirement, TR, we use, for example, this button for showing all edge pairs of the control flow graph. As you see, this is our graph. You can change the position of these nodes to show them properly. Okay. This could be the same as you see. Okay. This shape is the same as this control flow graph. Okay, this is similar to our control flow graph by defining all edges of our graph. The tools automatically construct our control flow graph and defines 12 requirements for edge pair coverage. All edge pairs are listed below this section for edge pair coverage. You can see simple pass test requirements and prime passes as well as you see for edge pair coverage. So we want to have some test passes to cover all of these test requirements. To have test passes, to show test passes, you can use these buttons to generate test passes to coverage each test requirements of each coverage criteria. As you saw, all edge pairs are these 12 edge pairs, and to cover these 12 edge pairs, we push this button to show the necessary test passes. As you see in this table, we need 3 test passes to cover all edge pairs. There are 2 test sets. The first test set is shown at this box, and the second one is shown by this test box, and then by this box. You see that, as you see, this table shows each test pass and what test requirement could be covered by a test pass. Okay, this test pass covers all of these test requirements. If you check this test requirement and compare with the test requirements that are pushed, that are covered by the first test pass, you see that this edge pair is common with the previous one, and this is possible for other edge pairs. Okay, you can use this web-based tool to generate prime pass coverage. For prime pass coverage, we should use more test passes. As you know, two algorithms are defined to do these tasks, the algorithm 1 and the algorithm 2, and there are some illustrative statements for describing these two algorithms at this part of the web page. You can use the second algorithm to prime pass coverage and see different test passes for, as you see, the second algorithm defines more test passes to cover all prime passes. Okay, so you can use this online web tools to generate your test requirements and test passes according to your test requirements for each control flow graph. As you know, these algorithms are so fast to generate test passes, and there is no need to do them manually. Okay. The time is over. Let me see your messages again, especially the long messages. The link I have introduced this page several times previously. You know this page. You have informed to this page, and there is no need to send them. You have downloaded your PowerPoint slides from this home page, and in the other sections of this home page there are these tools are described and informed to you. Can we find the best pass? As you know, I talked about the passes, the test passes enough in previous lectures. As you know, this problem is not decidable. So it's impossible to assert some test pass be the test pass, especially be the best test pass, especially in the presence of loops, of several loops, internal loops, and so on. Okay, let me read your long messages. As you know, and the rest of the professor knows that the sound on the platform is not clear, especially when the mic is open. So all the professors upload assignments and projects. Excuse me, I talked enough about this problem in previous lecture. So we ask you to put the assignments and projects on the LMS, and so that we can write the answer beautifully. I'm sorry I explained this point several times. I want you represent your works lively online. I want to ask you some several important points of your paper, your research paper. I believe that those questions will help you to learn and study more deeply in future, especially in your thesis. in doing your thesis. And I have several other students in Iraq. Now that all of them used your infrastructure again to explain their projects, to illustrate their representations, and we have no problem with them. They come from several states of Iraq, such as Kirkuk, such as Arbil, such as Soleimaniye, Dehok, Khanaqin, and Diyale state. Okay, we have no problem with them. All of them uses the same infrastructure in Iraq to represent their works. If you want, we can use the Skype infrastructure or Google Meet to set our sessions for represent your works. I want to have an oral exam. It's not acceptable for me to doing them offline. We have experienced several problems in doing offline homeworks. Most of them, excuse me, I'm sorry to say this sentence, most of them copied the homework from their friends, and at this time we have received 2 homeworks from your friends that they are copied. They copied from each other. Just the name of the student are different. I want to show those homework to you at this session. But I don't want to show the name of your friends. It's not acceptable for me to have offline exam, offline homework, and I want to have an oral exam. We all should turn on our webcam to see each other for the first time. It's not possible for me. Excuse me, I'm sorry. Please write anything you ask for, project or assignment. I've announced several times our assignments. The exercises that stated at the end of each section of your book, or at the end of each chapter of your book, all of them are our exercises. You should learn all of them. You should learn these concepts deeply. In your exam, for example, I open your PDF, your ebook, the textbook, and I go to the exercises arbitrary and ask you some questions related to these concepts. And as I told before, I have introduced you several video materials from YouTube. You can use these materials to support our lectures. If I have not taught very fluently and you have a trouble with my speaking, you can use these lectures. For example, for today lecture, you should use this part and this part of these lectures. This lecture is done by a prestige professor from India, and all of them about our textbook. You have no problem to learn these concepts. I don't know why you afraid from our exam and from your live representation, online representation. You should practice them, because you should start doing your thesis soon. You should defend from your opinion, from your ideas soon. There is no reason to skip the exam and doing offline homework. You should do them soon, and we should start your representation soon. We have no more time, no longer time to prepare yourself. If you had a trouble with this infrastructure, these elements, you can use the Skype infrastructure. We can use the Google Meet possibility to have more proper session. If you have a more problem, please explain me. At this time, I don't see a reasonable, a logical reason to postpone your representations. I have defined your representations at the first sessions, and you have enough time for doing your homework. I have